So as part of our discussion, I wrote an Arp Spoof Detector this morning with Scapy. Scapy is a nice little library that allows you to take packets apart and put them back together and do all kinds of things. So IP addresses and MAC addresses are in pairs because each IP address has to have a unique MAC address for the network to function. It's like earlier, I said, if we had two Jessicas in the room, how do we know which Jessica is which? Well, we'd have to have a Jessica A and a Jessica B. Or a Bill 1 and a Bill 2. However, in a well-functioning network, these are all unique. And what does ARP do? ARP allows us to...
Sit back.
Nope. It's called Address Resolution Protocol.
Oh, yeah.
And it allows
resolve
us
IPs to MAC address.
excuse me?
To resolve IP to
Mhm.
MAC address.
Because in order for me to communicate with Mike, for example, my computer to communicate with Mike, I need to know his IP address. But the actual communication, that's layer 3. That's a logical layer. I can't really communicate on that layer. It has to be translated down to the MAC layer, which is the media access control. And what is media in a network? What is media in a network? Anybody, have I ever said anything like that before?
Was it physical
media.
wires and
Yeah. In networking, we refer to media as how the actual packets are electrically, by light, by radio waves. That's all the media, physical media. So the MAC address allows the network card to associate its MAC address with the packet that it actually sends over the wire as electricity. So my packet has my source MAC address, my source IP address. It has all the information about me. But I can't communicate directly by using a MAC address to anybody. That's part of the what's called the IP stack or the TCP IP stack. You have to go up and down and have things resolve. It's like going from google.com to an IP address. That uses what for name resolution?
IP? What?
We're going from google.com.
DNS?
DNS, yeah.
From name to IP?
Yep, and then from the IP, we use ARP to find where we send our packet actually on the wire. All right. So that's why we need the ARP part of this in here, and sniff is so we can see what's going on over the wire. If you don't have Wireshark installed, or what's the other open source thing that we installed that has NPCap in it? ZenMap. If you've installed either one of those, you have the NPCap, because we need a capture plugin in our network stack so we can see in programs what's going past our network. Now, of course, Linux is superior networking. It has all that built in. It's much better at that low-level networking stuff than Windows. With Windows, we have to add everything in and it's afterwards. All right, so we have our empty ARP table. We go down to here. Here's our main. We're starting ARP spoofing detection. Sniff means that we are looking for packets. We only want ARP packets. We don't care about anything else going by except ARP packets. If we didn't have the filter in there, we'd see all kinds of stuff. We only want ARP packets. Okay, if we see an ARP packet, we run this guy. So this is like a event-oriented thing. It sits there in the background waiting for something to happen. It doesn't do anything until it sees an ARP packet, then it runs this. And this is just in here. We don't want to store anything. We just want to look at each ARP packet as it goes. I've used this in something else before. That's where I got that. Oh, the ARP Monitor program that I did. All right. So the next thing we want to do is, and I think I used this in the ARP Monitor program, if the packet has an ARP layer, so that means, does it have a layer that is specifically an ARP packet? And in this case, we're getting pretty fussy. There's two types of ARP packets. Number 2 is an ARP reply, because we have two types. I think that's right. Two types of ARP packets. One is a broadcast saying, hey, who has 10.0.1.55? And then a response or a reply would say, Sean would say, hey, I've got 10.0.1.55. My MAC address is, And that's all there is to the ARP protocol. There's just a broadcast and then somebody replies. It doesn't have to be you. It could be somebody else if they know MAC address. That's how ARP works. It's very chatty, but it only has a couple packets. Chatty meaning that it sends stuff to everybody. I think of that as chatty. So it has to be in our protocol and it has to be only a reply. Okay, so once we have that packet captured, we can analyze it because the packet, we want to look for the PSRC.
Source.
Yep, that's the IP source address. And HWSRC is the hardware source address, which would be the MAC address. Because at this point, we have the whole packet and we can dissect whatever part out of it that we want using these little, I guess they'd be attributes or properties of this object, this packet object. Might be a one way to look at it. Because this packet object is created when we sniff something and it has all this information in it. So if, ooh, this looks like something we were just talking about earlier, when we're looking at the dictionary. If something is a way Python has to see if something exists in an ARP table. And what is our ARP table? It's a dictionary. So this refers back to the other one. If such and such exists, we're going to see if the MAC address has changed. Otherwise, we add it to the list. I'm sorry, dictionary. Right, we add it in if it's not there already. So we are saying if the ARP table, oh, that should really be .get IP, shouldn't it? To be safe. Yeah, I said I always use that, and then here I didn't use it. Whenever we're retrieving something, so this would be the key value. If this has not changed, if the MAC address has not changed, if the one that's in there is not the same as this one, sorry. We're getting the current MAC address. If that MAC address is not equal to the MAC we have in storage, we have a problem because the MAC address changed. So I had to think about that for a second. I always have trouble with the not equal to part. And what I probably should have done, now that I think about it, is done this ahead of time. So it'd make more sense. So what I'm doing is I'm getting the, we'll just say MAC. We have to call it something else. I don't know.
Original MAC.
Yeah, that's a good one. Original MAC. Because that'll make more sense. I don't always do it original, but I try to do one thing at a time, except I don't always do that. But so this would be the original, it should be MAC, because that's a good name. The original MAC address that's in the table, if the original MAC address is not equal to the one that we just pulled out, right? Because that one came in from the packet we just pulled out. If it's not equal, then somebody is messing with our network. I think that makes more sense if we pull it out first. Oh, and I didn't do a .get here either, did I? Well, I just did this morning, so it was very quick there. And I did this because otherwise the string would go off the screenshot and then you'd have a hard time reading it. Otherwise, we add it in. So there's a use for a dictionary. Whenever you have values and keys that have to match, you use a dictionary. So what good does this do us? I don't know. It allows us to learn more about MAC and IP addressing, and we have an ARP spoofer detector that we built on our own. So let's see if it works. Did I start up my machines? I did. Okay, I did. So where we want to go, and I just ran this on Kali Linux. I didn't run it on the Windows machine because to run it on the Windows machine, we'd have to install Python. And I thought, okay, that's a pain in the butt. Linux, of course, being the superior networking machine that it is, already has Python in it. It is, and Mac already has Python in it. You know, what can you do? Windows falls down on these kinds of things. But I do want to set a target. And this is my target. Oh, I logged into the wrong thing. I logged into my domain, which does not exist right now because my server's not running. So we are going to take our same thing that we've been doing with our better cap, and this darn well should work because it worked this morning. Yeah, I've said that before, haven't I? Let me find my destructions, assignments. And we go to better cap, and here it is. We're going to detect ARP spoofing. Nobody's going to get past us. All right. So we go to our Linux baby. And I think I already have the better cap file in here. Let's see. There's my better cap folder. Yep. CD better cap. And in here, I already have I don't know if I have a different one in here. I'm not sure why I do, but I'm just going to copy this one and put it in. Replace that one with it. GME and where's my caplet file? Spoof.cap. Oh, there it is. Whoops. I blame it on having some sort of infection in my brain, lungs and everything. So this is slightly different. I don't know if I need to add this other stuff. But I didn't try it without it. I just went with the one that was in the assignment. All permission denied. What does that mean I should do there? Jessica or Andy, or if I'm denied permission, Andy, Jessica, or Sean, what does that mean I should do to fix
Sudo.
that? Good, Sean, you're cooking. Sudo.
I was gonna say cry.
Yeah, well, there is no crying in IT. I keep telling you that.
No crying in baseball.
That's right. There's no crying in IT either. There it is. There's not a lot of difference between those two. This one's added in. I don't know if it matters. Anyway, it doesn't hurt. So I'm going to bring up another terminal because I didn't want to install all this kind of gunk into Windows. So I'm going to bring up my other terminal. And here I'm going to create my, let's see, ARP Spoof Detector. .py. There it is. Oh, it's empty. I need to find him and copy him and paste him. There it is. Now in Windows, you have to install Scapy. I don't know if Scapy is installed as a normal library in other Linux distributions, but it is part of Kali Linux because it's used for lots of different stuff. So there it is. Ta-da. Now, whenever you deal with the network or any underpinnings of Linux, yes, you do have to use sudo. Otherwise, it'll say, oh, I can't access the network stuff. And let's see if we're having anything going on right now. It should not do anything at all.
Python.
Oh, yes, you're right. Unless I change mod to it. Anyway. Oops. Yeah, I have to say where the interpreter is, and there it is. We're looking for ARP spoof detection. All right, let's run our better cap. Just like we've done before. And this is just sitting with its little sniff thing, just waiting for something to happen. You know, it says, okay, I'll just twiddle my fingers until something actually happens. Oh, what I don't know is if I have the right address. Let's see here, if I have the right address for my Windows. Because at home it was 10.1.6, it could be different here. All right, what is our IP address? How do I find my IP address? Yes, our friend. If you haven't memorized this after a year and a half, you're not paying attention. Oh, why is it doing 10.10.1.100? Oh, I remember. I had to do a DA address. I have to change my spoof file. For some reason, it has 10.10.1.100. I don't know. We'll see if we're both on the same network. Ping. Let's see. 10. Well, I'll hope that it works. If not, I'll troubleshoot later. So I need to change my spoof.cap file. There we go. this has to match. 100. Oops, no, it's not on. There. All right, our monitor's been waiting all this time and saying, boy, I'm getting pretty disappointed. There's no spoofing going on. That's my entire life, is watching for spoofing. All right, let's see if this works. There we go. Now, what I discovered doing this morning is sometimes I had to actually like initiate some traffic here, doing something. So I just pinged 8.8.8.8. Whether I can get there or not, I don't care, but I had to generate traffic. Oh, I bet we're not on the same network because that worked this morning. All right, we'll stop it and start it again. See if that works. Then the next thing we'll do is troubleshoot, make sure we're actually on the same network. Oh, there we go. I know I had to stop and start a couple of things. I had to generate traffic and stop and start BetterCap. Look at that. We're detecting all kinds of things. And by the way, I put in the FBI's cyber email address in there. So every time you guys do this assignment, it's going to email the FBI that you've been spoofing, doing a MAC spoofing address. Anyway, if you have, for instance, a firewall that detects this kind of stuff, that's what it's doing. It's looking for this stuff. It's sitting there waiting for bad things to happen. So that would be a HIDS or an host intrusion prevention, or host intrusion prevention.
HIPS.
HIPS, host intrusion prevention, which includes detection. And what we have on my firewall is I have a network intrusion detection and network intrusion prevention, but that's the kind of thing it does. It looks for anomalies in the network. Because if all you do is look for things that have signatures, well, they have to be updated all the time. And so the modern way to look for things is to look for anomalies, things that don't look right, that don't look like normal traffic. So you look for anomalies in the network. And do I want to quit? Yes, because it actually worked after I wiggled around a little bit. It worked just fine. So is that a useful tool? It's more what I call a proof of concept, meaning it gives you an understanding how HID or NID systems work.